Lesson 31 activities. We're going to solve some equations. Solve the following exponential equations. So 2 to the x equals 14. The exponential is already isolated. I'm just going to take the ln of both sides. I can now bring the x down in front. X times the ln of 2 equals the ln of 14. Divide both sides by ln 2 to isolate the x. The ln 2's cancel, so I get x equals ln 14 over ln 2. That is the exact answer. You can type that into your calculator to get an approximate answer if you're interested. ln 14 divided by ln 2 is approximately 3.807. But typically, the exact answer is what you're going to be asked for in your homework and on quizzes and tests. Solve e to the 5x equals 17. Similar approach here. Ln of e to the 5x equals the ln of 17. Take the ln of both sides. Bring the exponent down, so you have 5x times the ln of e equals the ln of 17. The ln of e is 1, so this just says 5x equals the ln of 17. Divide both sides by 5, so x is the ln of 17 over 5. 2 to the 1 minus x equals 3. Take the ln of both sides. Bring the exponent down in front, so you have 1 minus x times the ln of 2 equals the ln of 3. I think I'll divide both sides by the ln of 2 and just get that out of here. So I have 1 minus x equals ln 3 over ln 2. And then I need to get the x by itself. So I think I'm going to subtract 1 from both sides. So I have the opposite of x, right? My 1's cancel, but I still have a negative in front of that x, is ln 3 over ln 2 minus 1. And then I'm going to multiply both sides of the equation now by negative 1. So I have x equals negative ln 3 over ln 2 plus 1, or positive 1 minus ln 3 over ln 2. All right, now I'm going to solve some log equations. The properties are here just for our reference, but we all have those memorized now. No need to write them down. So my log expression is already isolated, so I'm just going to change this to an exponential equation. The base is 4, the exponent is 2, and it equals 2x minus 1. So 16 equals 2x minus 1, and just solve for x. 17 equals 2x, so x is 8.5. All right, this one I have 2 logs, so I'm going to compress them into a single log using my properties. Those are separated by addition, so I can compress them via multiplication. So this says log of x squared minus 3x equals 1. And now change it to an exponential equation. There's a little invisible 10 here, so this says 10 to the first equals x squared minus 3x. And now I have a quadratic equation. Move everything to one side, so I have x squared minus 3x minus 10 equals 0. And does that factor? Yeah, I could factor this to x minus 5 times x plus 2. So that means that x equals 5 or negative 2. But especially when you get 2 answers, you need to check your domain, right? See if you can plug 5 and negative 2 in here. Log of x, remember you cannot put a negative into a logarithm, so we definitely have to eliminate that x equals negative 2 as our solution. I can take the log of 5 and I can take the log of 5 minus 3 because that's positive 2. So x equals 5 is my only solution here. Write your own application for which the answer would be the solution to the following equation. So basically, you would have 1,000 things that are growing at 3% per day or week or year, how many days or weeks or years until you have 5,000 of those things? All right, let's solve some application problems now. Several classes ago, we talked about rabbits that started with 1,000 rabbits and the population doubled every year. So how many years until there are 50,000 rabbits? So we have 1,000 rabbits. We double it over and over again. That's times 2 to the t. How many doublings until we have 50,000 rabbits? So I just want to solve this thing for t. So first thing I have to do is isolate 2 to the t. So I'm going to divide both sides by 1,000. So 2 to the t equals 50. Take the ln of both sides. Bring the t down in front. So this says t ln 2 equals ln 50. And then to get the t by itself, you divide both sides by the ln of 2. So t is going to be the ln of 50 divided by the ln of 2. Now, application problems are the exception to the rule where you don't want to give your answer as an exact value. If somebody asks you how many years it will take and you answer ln 50 over ln 2, that's kind of obnoxious, right? So we're going to get an approximation for the person who asked this question. So we do ln 50 divided by the ln of 2, and we get about 5.64 years. All right, here's an application problem for a log equation. The percentage of adult height attained by a girl who is X years old can be modeled using this log equation. X represents the girl's age. You can plug in any age from 5 to 15. And f of x tells you the percentage of her adult height. So at what age, rounded to the nearest year, has a girl attained 97% of her adult height? So my input is age and output is height. So I'm going to put 97 as my output. And I want to solve for x, age. So I want to isolate the logarithm first. So I'm going to subtract 62 from both sides. 97 minus 60 would be 37 minus another 2 is 35 equals 35 log of x minus 4. Divide both sides by 35, so I get 1 equals log of x minus 4. And then change this to an exponential equation. There's a little 10 here. So this is 10 to the first equals x minus 4. And add 4 to both sides, so I get x is 14. So at 14 years old, a girl has attained 97% of her adult height. All right, so these are just some sort of special techniques for log equations and exponential equations. So the first technique is if you have logs on both sides of your equation and no constants, if you can make it look like log of some stuff equals log of some other stuff, you know that your two stuffs are equal. Okay, so step 1 is to combine the two logs on the right. So I have the left, I'm just copying the ln of x minus 3 equals, I'm going to combine these using the quotient rule, the ln of 7x minus 23 over x plus 1. So now I have the ln of A equals the ln of B, and that means that A has to equal B. So I can set x minus 3 equal to 7x minus 23 over x plus 1. Multiply both sides of the equation by x plus 1. So on the right, my x plus 1's cancel. So I just have 7x minus 23. On the left, I can multiply those together and I get x squared Minus 3x plus x is minus 2x minus 3. And now I have a quadratic equation. So I'm going to put everything on one side. So I have equals 0. X squared, negative 2x minus 7x is minus 9x. Negative 3 plus 23 is plus 20 equals 0. This factors to x minus 4 times x minus 5. So x equals 4 and 5. Now, like I said, especially when you have two solutions, you should go back and check in your original equation. So 4 and 5. If I put 4 here, I'm good. 4 minus 3 is 1. I can take the ln of 1. If I put 4 here, 7 times 4 is 28, minus 23 is 5, I'm good. And I'm good here. And so 4 and 5 both work, but I should check, both work in terms of domain, but I should actually check that this is true. So I'll just do it all on my calculator. Let's see, the ln of 4 minus 3 is 0, and then the ln of 7 times 4 minus 23 minus the ln of 4 plus 1, also 0. So the left side is 0, the right side is 0, so 4 is a solution. Now I'm going to redo this with 5. Put a 5 in here. ln of 5 minus 3 is 0.693. And then I'm going to do the ln of 7 times 5 minus 23. Oops, I didn't mean to close that parenthesis. Minus 23 minus the ln of 5 plus 1. And I also get 0.693. So those are both actually solutions. And so I can go ahead and circle them. All right, with this one, we have an exponential equation, but it also looks a little bit quadratic. There's like a squared and a first and a constant. So I'm going to let u equal e to the x and rewrite my whole equation in terms of u. So that means that all right, so let's just do a little side work here. U squared would be e to the x squared, which means that u squared is e to the 2x. So where I see an e to the 2x, I can rewrite that as u squared. E to the x is u, so it's minus 4u plus 3 equals 0. Solve the resulting quadratic for u. So this is u minus 3 times u minus 1. So I get u is 1 or 3. And then set each u value equal to e to the x, right? Because go back to the substitution you made. If u equals e to the x, replace each of these u's with a 1 and a 3. So I get 1 equals e to the x, or 3 equals e to the x. We take the ln of both sides. So I get x's, the ln of 1 is 0. And here I get x is the ln of 3. And then you should go back and check both of them. So if x equals 0, e to the 0 is 1, minus 4 is negative 3 plus 3 is 0. So that works. And ln 3, I'll let you check that on your own. But it is actually a solution.